We have to correct the following exercise for application. It goes sketch the following quadratic functions. Here we have y equal to x squared plus 6x plus 5. We take solution. Here we have y equal to x squared plus 6x plus 5. First thing, we need to start by finding the x-intercept. For us to get the x-intercept, we are going to equate y to 0. Y is equal to 0, then x squared plus 6x plus 5 must be equal to 0. Now we need to solve this quadratic equation for x. We need two numbers such that when we add them, we obtain 6, and when we multiply the same two numbers, our answer will be 1 times 5, which is 5. You see that the two numbers must be 1 and 5. 1 plus 5 gives 6. 1 times 5 gives 5. This will give us x squared plus, we are going to replace 6 here with 1 plus 5. 1 plus 5 times x plus 5 is equal to 0. This will give us x squared plus, we are going to expand this bracket. 1 times x gives us x plus 5 times x gives us 5x plus 5 is equal to 0. For these two terms, we know that x is common. We are going to factor out x times x plus 1 plus these other two terms. We know 5 is common. We are going to factor out 5 times x plus 1 is equal to 0. Now we have two terms. X plus 1 is common. We are going to factor out x plus 1 times x plus 5 is equal to 0. Now at this level, we are going to see either x plus 1 is equal to 0 or x plus 5 is equal to 0. Now if we find x here, x will simply be equal to, we are going to transfer 1 to the right hand side, which gives us negative 1, or x will simply be equal to, we are going to transfer 5 to the right hand side, which gives us negative 5. It therefore means the points negative 1, 0, negative 5, 0 are the x-intercepts. Now we need the y-intercept. For us to get the y-intercept, we are simply going to put x equal to 0 when x is equal to 0, y will simply be equal to 0 squared plus 6 times 0 plus 5, and this will be equal to 5. We have the point 0, 5 is the y-intercept. Now the next, we need now to find the maximum or minimum point. Maximum minimum point. We are going to use the method of computing the squares. We have y equal to x squared plus 6 x plus 5. This will simply be equal to x squared plus 6x plus, we know the coefficient of x here is 6, and the half of 6 is 3, plus 3 squared plus 5, we are going to subtract 3 squared. This will give us, we know this is a perfect square, and the factorization is simply x plus 3 all the square plus 5 minus 3 squared gives us 9. This will simply be equal to x plus 3 all the squared. We know 5 minus 9 gives us negative 4. We know that for every x we take from a set of real numbers, x plus 3 all the squared is greater than or equal to 0. Next, if we add negative 4 at the left hand side and at the right hand side, this will give us x plus 3 all the squared minus 4 is greater than or equal to 0 plus negative 4 gives us negative 4. We know this is y, so this will give us y is greater than or equal to negative 4. For all x we take from a set of real numbers, we know y is a function of x. In this case, it simply means y equal to negative 4 is the minimum value. Y equal to negative 4 is the minimum value of y equal to x squared plus 6x plus 5, which occurs when x plus 3 all that squared is equal to 0, when x plus 3 squared is equal to 0. X plus 3 all this squared equal to 0 would simply imply that x plus 3 is equal to 0. Then x will be equal to negative 3. It simply means the point negative 3 for x, negative 4 for y is the minimum point. Now, after getting the minimum point, we go now to the symmetry. Right? For the symmetry, we simply know we are going to solve this equation. So we are going to conclude x equal to negative 3 is the symmetry, the line of symmetry. Line symmetry. Knowing all this, we can easily draw the curve of y equal to x squared plus 6x plus 5. Let's scale our graph. And this is the y-axis. Next, we need to draw now the x-axis. This is the x-axis 0, 1, 2, 3, 4, 5, negative 1, negative 2, 3, negative 4, negative 5, negative 6, 1, 2, 3, negative 4, negative 2, negative 3, negative 4, negative 5, negative 6. Now, we need to start by plotting the intercepts. We know for the x-intercepts, we have negative 1, 0. When x is negative 1, y is 0. Put it here. Next, we have negative 5, 0. Now we move now to the y-intercept. For the y-intercept, when x is 0, we have y as 5. So on the y-axis. Now the next thing we need to plot the minimum point. We need the minimum point. When x is -3, y is -4. We meet here, we put a dot. Next thing now, we have to connect these 4 points. The smooth curve, the curve goes as such. Connect them, goes down, goes up, continuous. Label this. This is the curve of y equal to x squared plus 6x plus 5. Now the line of symmetry. Our line of symmetry is simply x equal to -3. It's our line of symmetry. Indicate this is x equal to -3. This is the line. And this is our minimum point. Now let's move to question B. For question B, we have y equal to 3x squared minus x minus 2. The first thing, for the x-intercept, we're going to equate y to 0. Y equal to 0, then 3x squared minus x minus 2 is equal to 0. We need two numbers such that their sum is equal to -1. The product of the two numbers is equal to 3 times -2, which is equal to -6. The two numbers would be 2 and -3. 2 plus -3 gives -1. 2 times -3 gives -6. This will give us 3x squared plus, we're going to replace -1 in the equation of x. 2 plus -3, which is the same as 2 minus 3 times x minus 2 is equal to 0. This will give us 3x squared plus, we are going to expand this by 2 times x gives us 2x. -3 times x gives us -3x minus 2 is equal to 0. At this level, you see that if you look at these two terms, x is common. We are going to factor x. We'll be left with 3x plus 2. These other two terms, we are going to factor -1. We'll be left with 3x plus 2 is equal to 0. Now we have two terms. 3x plus 2 is common. We're going to factor 3x plus 2 times x minus 1 plus there's -1 is equal to 0. At this level now, we are going to say either 3x plus 2 is equal to 0 or x minus 1 is equal to 0. This is a linear equation. This will give us 3x will equal to, we are going to transfer 2, which gives us -2, or in this other case, x will simply be equal to 1. We transfer -1 to the right, it becomes positive. Here now, for us to get x, we are going to divide both sides by the equation of x, which is 3. 3 will cancel 3. X will simply be equal to -2, 3. Now, we are going to conclude that the points -2, third, 0, and 1, 0 are the x-intercepts. So these are the points where the curve cuts the x-axis. For the y-intercept, for us to get the y-intercept, we are simply going to put x equal to 0 when x is equal to 0. Y is simply equal to 3 times 0 squared minus 0 minus 2. And this will be equal to, 3 times 0 squared is 0, minus 0 is 0. 0 minus 2 gives us negative 2. This will give us the point 0, negative 2 is the y-intercept. Now the next thing we need to find is the maximum and minimum point for the maximum or minimum point. This is what we need. When we are going to make use of our method of completing the squares, we have y equal to 3x squared minus x minus 2. First thing, we are going to factor out 3, which is the coefficient of x squared. We have x squared here minus 1/3 x minus 2/3. Looking at this, the coefficient of x is negative 1/3. And the half of negative 1/3 is simply negative 1/6. This will give us 3 times x squared minus 1/3 x plus negative 1/6 squared minus 2/3. We are going to subtract negative 1/6 squared. Close the bracket. This will simply be equal to 3 times, we know this is a perfect square, and the factorization is simply x minus 1/6. Because if we take x plus negative 1/6, negative sign will stay squared, minus 2/3 minus negative 1 squared gives us 1, all over 6 squared gives us 36. We close the bracket. This will be equal to 3 times x minus 1/6, all this squared, plus the LCM of 3 and 36 is 36. 36 divided by 3 gives us 12. 12 times negative 2 gives us negative 24, minus 36 divided by 36 gives us 1. 1 times 1 remains 1. This will give us 3 times x minus 1/6, all this squared. Negative 24 minus 1 gives us negative 25. We know positive, negative will stay. Negative 25/36. We are going to multiply these two terms by 3. This will give us 3 times x minus 1/6, all this squared, minus, we 3 will go into 36 here, 12 times minus 25 all over 12. For every x, take from the celebrating numbers, x minus 1/6, all this squared is greater than or equal to 0. And the only case when you will have 0 is when x is equal to 1/6. Now if you multiply both sides by 3, 3 times x minus 1/6, all this squared is greater than or equal to 3 times 0. This will give us 3 times x minus 1/6, all this squared is greater than or equal to 0. Next thing, we are going to add negative 25/12 at the left hand side and at the right hand side. This will give us 3 times x minus 1/6 squared minus 25/12 is greater than or equal to 0 plus negative 25/12 gives us negative 25/12. We know that this is simply y. Y is greater than or equal to negative 25 over 12 for all x we take from a set of real numbers. We know y is a function of x. It simply means the smallest value we are going to have for y will be negative 25 over 12. If we write this down, y equal to negative 25 over 12 is the minimum value of y equal to 3x squared minus x minus 2, which occurs when this is equal to 0, when 3 times x minus 1 over 6 all this squared is equal to 0. We are going to solve this equation for x. 3 times x minus 1 over 6 all this squared equal to 0. Then if we divide both sides by 3, we'll be left with x minus 1 over 6 all this squared is equal to 0. Next, if we take square root on both sides, we're going to retain x minus 1 over 6 is equal to 0. Then x will simply be equal to 1/6. Now we are going to write down the minimum point. For the minimum point, we have 1 over 6 for x, comma, negative 25 over 12 for y is the minimum point. Next thing, now we need the line of symmetry. The line of symmetry. For us to get the line of symmetry, we are simply going to solve for x when we equate 3 times x minus 1 over 6 all that squared to 0, which is simply what we have done here. We are going to write this down. X equal to 1 over 6 is the line of symmetry. Knowing all this, now we can sketch our function y equal to 3x squared minus x minus 2. We're going to label our axis. This is the x-axis, the y-axis, the origin. Looking at the values of x and y for the intercepts and the maximum value, we are going to make use of a scale of 2 squares, 1, 2, 1, 1, 2, 2, 1, 2, negative 1, 1, 2, negative 2. This is negative 1, negative 2, negative 3, 1, 2. Because the values are very, very small. First thing, we need to start by plotting the intercepts. The first one, we have negative 2/3. We know negative 2/3 is approximately negative 0 point something. So it is very close to 0 from this direction. We can assume this is our negative 2/3. Then y is 0, so they meet here. This is the point. Then for the second intercept, we have x is 1, y is 0 here. Now we go now to the y-intercept. Y-intercept we have x being equal to 0, y is equal to -2. This here. Now we need the minimum point. For the minimum point, we have x to be equal to 1/6. 1/6, we know it is very close to 0. Then y is equal to -25/12. -25/12 is approximately -2 point something, which is down here. Let's assume this is our -25/12. The limit here, somewhere around here. The dot. Now the next thing we have to connect 1, 2, 3, 4 points. We are going to have something as such. Connect the points. Close up. This one we will have. We level the curve. This is y equal to 3x squared minus x minus 2. And our line of symmetry will simply be x equal to 1, 6. This is the line of symmetry. This is 8. X equal to 1/6. And this is our minimum point. We go now to question C, the last question. C, y is equal to 6x minus 2x squared. We can arrange this as -2x squared plus 6x. First thing, we need the x-intercept. X-intercepts. For us to get the x-intercepts, we are going to equate y to 0. Y is equal to 0, then -2x squared plus 6x is equal to 0. We are just going to proceed with the factorization. We saw this when we were treating how to solve quadratic equations by factorization. Here, between these two terms, you see that 2x is common. You can factor 2x times -x plus 2 times 3 gives us 6. X 3 is equal to 0. Then 2x will be equal to 0, or -x plus 3 is equal to 0. This will give us 2x, divide both sides by 2, or here we are going to transport 3 to the right hand side. This will give us -x is equal to -3. This will give us 2 cancel 2, x will be equal to 0 divided by 2, which is 0, or for us to get x in this case, we are going to multiply both sides by -1. -1. Now -1 times x gives us x, is equal to -1 times -3 gives us 3. Now we are going to write down our intercepts. We have points 0, 0, x is 0, y is 0, and we have 3, 0, and the x-intercepts. Now the next thing, we need the y-intercepts. Y-intercept. For us to get the y-intercept, when x is equal to 0, y will simply be equal to, we're going to replace x with 0 here. 6 times 0 minus 2 times 0 squared. This will simply be equal to 0. We have 0, 0 as the y-intercept. Remember, the point 0, 0 is the origin. Now we need to find the maximum or minimum point. We are going to make use of our method of completing the squares. We have y is equal to negative 2x squared plus 6x. First thing, we are going to factor out the negative 2 to make the equation of x squared 1. This will give us x squared. We know negative 2 times negative 3 will give us 6, positive 6 times 3x. We know the equation of x here is negative 3. We are going to add the equation of x, all that squared, plus negative 3 over 2 squared. Then we are going to subtract negative 3 over 2, all that squared again. This will simply be equal to negative 2. Remember, this is a perfect square. We can factorize it. The factorization will simply be negative 2 in our bracket times x plus negative 3 over 2, which is the same as x minus 3 over 2, all this squared minus, now we are here, negative 3 squared gives us 9, over 2 squared gives us 4, we close the bracket. So this will be equal to negative 2 times x minus 3 over 2, all this squared, negative 2 times negative 9 over 4 becomes positive. We know 2 going to 4 2 times 9 over 2. Now at this level, we know that for every x we take from the set of real numbers, we know that the x minus 3 over 2, all this squared, will be greater than or equal to 0. Now we are going to multiply both sides by negative 2. Remember, if you multiply both sides by negative 2, the inequality sign is going to change. This will give us negative 2 times x minus 3 over 2, all this squared, less than or equal to negative 2 times 0. This will give us negative 2 times x minus 3 over 2, all this squared is less than or equal to 0. Next, then we are going to add 9 over 2 at the left hand side and at the right hand side. This will give us negative 2 times x minus 3 over 2 squared plus 9 over 2 is less than or equal to 0 plus 9 over 2 remains 9 over 2. This is y. We are going to say y is less than or equal to 9 over 2 for all x belonging to the set of real numbers. Remember, y is a function of x. This is our y. It simply means for all values of y we take, they are either less than 9 over 2 or equal to 9 over 2, which simply means y equal to 9 over 2 is a maximum value. Write it down, y equal to 9 over 2 is the maximum value of y equal to 6x minus 2x squared. Now we need to find the x coordinate of this maximum value, which occurs when this is equal to 0, when negative 2 times x minus 3 over 2 squared is equal to 0. Negative 2 times x minus 3 over 2 squared is equal to 0. Then we divide both sides by negative 2, x minus 3 over 2 squared will be equal to 0. Next, if we take square root, this will give us x minus 3 over 2 equal to 0. This will give us x to be equal to 3 and 2. Now we are going to write down the maximum point. The maximum point we have 3 over 2 as x coordinate, 9 over 2 as y coordinate is a maximum point. The next thing now we need the line of symmetry. The line of symmetry. For us to get the line of symmetry, we are simply going to equate the negative 2 times x minus 3 over 2 all that's equal to 0. Then we solve for x, which is just what we have done. We are going to write x equals to 3 over 2 is the line symmetry. We take note, the x coordinate of the maximum point or the minimum point is always the line of symmetry of the quadratic function. Now, knowing all this, we can sketch our function. Is the origin 0, the y-axis or x-axis 1, 2, 3, 4, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Now the first thing we need to start by plotting the x-intercepts. We have 0, 0, put a dot, which is at the origin. The next one we have 3, 0, put a dot. Next we have to plot the y-intercept. The y-intercept is 0, 0, which is the same as the x-intercept. Now the next thing now we move to the maximum point. For the maximum point we have x as 3 over 2. You know 3 over 2 is 1 point something, 1.5, which is somewhere around here. Then we have 9 over 2, which is 4.5 here. The two lines meet here. We're going to put it dot. And where they meet, we are going to connect these 3 points. For curve, we need to have something like this. Goes down, goes here, then it goes down. So now we need the line of symmetry. We know the line of symmetry is simply x equals to 3 over 2 for it. Broken lines. This is the line. X equal to 3 over 2. Then we know this is quadratic function y equal to 6x minus 2x squared. And we are done with the correction of the exercises for application. If in case you have any worries, make sure you ask your questions in the comment section. Please like the video, share, and subscribe to this YouTube channel. Thank you very much for watching.